when whales from different dialects and different units spend some time in the vicinity, they start picking up a little bit of the accents of the other. So there is all this social learning going on.
The next session, you know, if your mind is not already blown, it's going to really be blown by this, because we're going to dive deep into the ocean and again look at the collaboration between humans and technology in a most creative, imaginative, positive way possible. And yet it comes with its own sort of, long tail of questions as well. But if I say this in a line, it is about human, non-human communication. AI, for the first time, is making it possible for human beings to imagine that they could understand other species. So while we are trying to create a new form of species, AI is also enabling us possibly to understand what animals are saying and what other species in nature are saying, to break that barrier between human and non-human communication. There's a fantastic array of people who are imagining this and doing it with the most incredible technologies, incredible imagination. They're geologists, marine biologists, AI scientists, researchers, technicians, of course funders, and it is called Project CETI, and we're very excited to have one of the key scientists of Project CETI here with us today. They're focusing on the most magnificent animal on the planet, the sperm whale, and what are the whales saying to each other? Do we have the right to listen in? Ladies and gentlemen, to look at this beautiful phenomenon, I'm going to ask you to welcome Giovanni Petri, but before that, a tiny window again into what we tune out of, to use Adam Ghazali's phrase, that we are channeling our attention to things that serve us, but so much infinite realities are still going on around us that we don't put our attention to. So a tiny capsule of that, and then we'll invite Giovanni on stage. Ladies and gentlemen, please welcome the most imaginative scientist that we have here, Giovanni Petri. Thank you for being here.
Thank you very much. This is nerve-wracking.
Nerve-wracking?
Yes.
Okay. Do a bit of Matthew Ricard's, contain your breath. Yes. Giovanni, as I said, it's just, we've been listening to so many audacious imaginations, but this idea that we could actually begin to understand what other species are saying, to even first think that yes, there are other species talking, we just saw that. All of nature is talking, and we are just so focused only on our own language, you know. So before coming to your project and the process of it, what you found, first take us into the ocean itself, you know. When you first got involved with this project, what was the most surprising, mind-shifting thing that happened to you?
Well, I would say that
Will you speak a little closer?
Yes, the most mind-shifting moment is when you realize that we are used to live in 2D, right? So this is our world. We live on Earth, and sometimes we go to the mountains. And then you start
thinking... Can everyone hear him at the back?
That you are in a world that is so limited. You know, there are other animals that live between the surface and deep, deep, deep down, 100 meters down. Every hour, they cycle between very different environments. And this environment is, as we heard actually in the video earlier, it's so rich with sounds and chemical signals, a whole perceptual world that we do not experience. And I think this is the first real change that sort of made me question, okay, how can we even begin to understand a species or multiple species that live in such different worlds? And how can we even try and translate what could they be talking about?
Yeah, this universe of sound phrase, Giovanni, the first time we chatted and we met, that really stayed in my mind, you know, because when you dive into an ocean, actually what you feel is a sense of silence, you know, and to know that beneath that, it plays into so many themes that we've been talking about, that they're infinite realities. We are just, I come back with that phrase that, you know, it's a species-specific construct in our geological niche, you know, that we only see reality as our species sees it, but there's so much reality is right contiguous next to us, and that's an amazing idea, you know.
I completely agree, and actually, even if you dive a bit, anybody who dives here, how many people dive? Okay, it's silence at the beginning, but then the sea is actually awash with sounds. You have snapping streams and corals, even fish make sounds, typically ugly sounds, but they make sounds, and whales sing, as we know. So the possibilities in this sense are enormous, and one of the biggest risks is to do exactly what you were saying, so project our expectations of what communication should sound or look like or be performed. And in our case, at least with whales, we have a good prior that sound is important, but the argument generalizes. How might mycelial networks communicate, plants communicate, right? So I think doing this exercise of taking into account the possibility of different types of communication opens our mind and opens our possibilities to sort of interact with them a lot.
So Giovanni, before again we begin to eavesdrop or what you have managed to understand, you know, evoke for the audience the majesty and the marvelousness and the mystery of the sperm whale.
So, just to give you a little bit of idea, these animals are huge. So, sperm whale male is 17 meters long on average. A female, which is are the main, you know, body of the society. These are matriarchal, matrilineal animals. They are 11 meters. And every day, their life is staying for like 15 minutes, 20 minutes, resting and chatting at the surface, clicking. They have a Morse-like language, and then dive down to about 700 meters, going from light to extreme pressures, low temperature, high, you know, complete darkness, change the way they perceive the world because they start echolocating and they perceive the world through sounds rather than through sight, and then come back up. And this is your life every hour of the day.
Right. So, you know, now come to the actual project CETI. David Gruber, who's one of the founders, you know, he was telling me that it first began with him wanting to focus the world's attention on the fact that, you know, the tiny microorganisms, and now after Pranay Lal, I think we'll all have a healthy respect for the bacteria in our body, the microbes in nature. You know, it's like an endless spectrum of consideration, which I think Matthew was talking about. But this idea of microbes, so David Gruber wanted to first focus attention on the little life forms on corals. And then he said, that's not dramatic enough to compel the world's attention, so you shifted to whales, you know?
Yeah, oh, sorry.
Yes, no, so I was going to ask you that, so how do whales talk? You know, how did you all even think that you could begin to crack that language? Give us the, you know, what is the basic alphabet that you now understand?
Let me step back 1 second from that. So the project really started a bit like a joke. You know, a marine biologist, a computer scientist, and a cryptographer walk into a room. And this was at Harvard, Radcliffe. And they started thinking about what can we do to bring the attention to conservation. Then they thought about whales. And, you know, in the 60s, Roger Payne discovered whale song. Okay? And then that sparked a revolution. You know, whale song is on the golden record on Voyager at the border of the solar system. It prompted many changes, including the stop to whale hunting. Okay? And it created the largest conservation movement to date. And that was only by hearing them. Now imagine what could happen if you could actually understand what they're saying. Okay. And the reason why we moved to sperm whales instead of whales, or humpbacks, for example, is because we do have many priors, many evidence that they could have culture. Actually, they have culture. We know they have dialects. Between different groups of units. They have a language that sounds Morse-like. They communicate in clicks that are collected in what we call codas, like little words. And once you start seeing all these phenomena together, then you can start thinking, okay, maybe there is some regularity in this communication system that we could construe as a language. And then the question is, can we find these regularities? How do we measure them? How do we understand what they mean? And then we have to link them to behavior and so on.
So when you say culture of whales, you know, that's an amazing thought. You all have found, correct me if I'm wrong, that whale families have different dialects. So one, you know, I don't know how many of you know that whales swim almost 32,000 kilometers a year. That's their migratory pattern. And, you know, they're making sound that is louder than a jet. And yet when they're in families, they have dialects. So do you already have enough data and, you know, help the audience understand what you mean by dialects? And then do you already have a data bank of all these kind of sounds?
So, of all the sounds, no, but we're doing okay. What I mean by different dialects is, I have spoken about these codas, which are these little words that whales use, you know, vocalize, these utterances. So different families, different vocal clans, as we call, use different repertoires of these codas. They use more one type, more another type, and so on. And so we can actually, depending on how you would speak if you are from, you know, northern Italy or southern Italy, I'm Italian. I'm not going to go into India because there are too many different actual languages. These are dialects. You can pick up the relative differences. And something else that we find is that, for example, when whales from different dialects and different units spend some time in the vicinity, they start picking up a little bit of the accents of the other. So there is all this social learning going on. And the problem is that these we could do with data that existed. And just to give you an idea, until Project CETI, effectively the collection was, there is a sailing boat with a microphone trailing in the water, and you're collecting sounds, and then you have to process that. The way we are trying to change this is to bring advanced robotics, advanced AI techniques to large-scale collection. So we now have enough data to be able to say that all these things we're discussing are there, and we're on the cusp of massive data collection. And just if I can spend one more time, so how does it work? And you have to imagine that we have buoys in the water. Our field work.
Sorry, you have what in the water?
Buoys, you know, basically floating stations, science stations with hydrophones that are going down a few hundred meters. And those are collecting, constantly listening to the water. We have drones with little tags that we smack very softly, very nicely on the whales, and they track what they say and their movement as they move down and they dive and so on. So this is the way we can actually collect together sound, communication, behavior, and try to put them together to figure out how this language works, if it's a language.
So, you know, I'm going to come back to the whale, but the technology here is itself a marvel. And like I was saying, it's this, you know, beautiful sort of collaboration with technology in this case. Again, going back to something that David had told me, and do help the audience understand, he was just saying, you know, about entering this other realm of existence, you know, outside the spectrum of your own physicality. You know, to even begin to understand that realm, you all first created something called the shark sight camera to see the world as the shark sees it. What did you find, and how do you even do that?
So the experience when we've seen all documentaries about underwater life, right, is that, you know, it's not very lively in terms of colors, you know, because the water absorbs a lot of the frequencies. It turns out that actually if you build cameras that see in the spectrum of many of the fishes, many of the sharks, for example, then you realize that many more, for example, species of fish are bioluminescent. So they have patterns on them that you wouldn't see. And so that there is
They have planktons.
patterns of bioluminescence on their skins and so on. And this means that there is also that type of communication and signaling, in that case, I would say, that goes on that we're completely blind to. And we actually, in this sense, we go back to the argument before about how many things we don't really perceive because we are watching through the different eyes.
So there's a kind of phonetic sound, a phonetic sight, acoustics. That's how other species are experiencing reality. Like we know a snake sees it through infrared. We know a bat is hearing a sound that we can't. We know dogs are hearing sounds that we can't. So, coming back to that idea that reality is not only what we perceive it to be, but, about the shark sight camera, it really captured my imagination. What did you all do, and what you said that the shark sees colors in the ocean?
So what you can do is that you can correct the absorption of the frequencies on your camera to account for the absorption of the water. And so you allow yourself to see. It's a little bit like when you do infrared cameras, when you see in the Navy SEALs movies and that kind of thing. You're seeing the frequencies that you don't usually see. The documentaries that you are shown are in the visible light for humans, but there are other frequencies that are visible for these animals and they're not so absorbed in water, and they can propagate. And if you use this shark tank camera, then you can actually bring them to our own perception, so we can see them too, and we see how, for example, sharks in this case, but also we believe other species in the water see their conspecifics and other animals and so on. And for example, with sharks, depending on the patterns on the skin, that can be actually a telltale of whether they're healthy or not healthy and so on. There are all these kind of additional informations that you can get, like you would do from seeing the color of the leaves of your plants. This kind of information becomes accessible.
Right. So, coming back to the whales, now that you all have got these basic parameters, that they are social clans, they are dialects, they pick up each other's accents, they sing, they talk, their sound goes beyond. This is another detail, that they make such large sounds that it's only the water that absorbs it. But if they made that sound on Earth, then we would die from that sound. It's that loud, which is another incredible detail. So how much have you all gathered when you said, yes, we have a large data bank? And are you beginning to see the first alphabets? What do you understand now about whales? And I'll come to the deeper questions you had shared with me.
So what we understand is that they do have some basic alphabet, which is a phonetic alphabet like we have, A, B, and so on. So they can modulate their codas in such a way by changing the rhythm, the length of the coda, where like you could say A, or you could say A, and then by changing this kind of parameters, they have a symbolic space they can use to put together codas of different types, like we would do with letters. But this is our working hypothesis right now. We do know that this type of communication is impacted by the vocal clans, but where you belong to one or the other, but the basic alphabet is there. And so yes, we expect them to be able to put together all these little pieces and have a very large space of possible symbols they can build. And so like similar to what we do with words, with languages and so on.
So the role that AI is playing in this is pattern recognition. Is it that you have all this data and it is beginning to find patterns of sound?
Yes, AI is fundamental for us, from flying the drones and attaching to the whales and flying fleets of drones and finding the whales, to finding patterns in how they move and whether, for example, different types of clans dive in the same way or in different ways, to, of course, what are the regularities in the language that they have. And, for example, the symbols, this basic phonetic alphabet that I was describing earlier was found by using modern AI techniques. It was like these were rather simple neural networks in that case because the data set wasn't huge, so you didn't want to overfit, shoot a bird with a cannon, but that's how it works.
So, just share with unfortunately we don't have that clip, but Giovanni, when we were chatting earlier, showed us this absolutely, again, humbling bit of footage that they got of a whale giving birth and how the entire clan behaved when and it's amazing that you got a giant sperm whale actually delivering a baby in mid-ocean. Do share the audience, and I'm sorry we couldn't get that clip for you.
So what happened is that, as I was saying, typically sperm whales spend very little time at the surface, and instead we found a large group that seemed to be there for a long time. and we didn't really understand what was going on. So after a while, these groups started becoming denser and denser and thrashing, and at some point there was a spurt of blood, and then this big, well, small sperm whale calf came out. Now a small baby, calf is 4 or 5 meters long, okay? So it's like a truck. And then what happened afterward is that we're seeing all these animals that were basically volleyballing the baby out of the water. And that is because babies, sperm whales, calves, when they're born, they're not buoyant, so they would sort of sink. So you need to keep them out of the water until they began to be able to swim, because their tail fin is bent when they come out. And the super interesting thing for us on top of this was that we saw different units, different families collaborating, cooperating together to do this. And we actually believe this is one of the most important observations, if you want, in the last 50 years of cetacean work, because cooperation across non-kin, so you're not helping your family, but you're helping someone else, we believe to be the basic of large-scale cooperation, and also why language might be so important, because you need to coordinate to do this. And so on.
Could all of you hear that? Yes, it's just, it was just, I mean, we actually saw it, but David Gruber has the clip, and, he's out in the ocean right now, so we couldn't get the clip in time. You actually see these whales coming together to lift this, newborn calf, like tossing it out of the water, like we rock a newborn baby, and different clans coming together, collaborating to do this. It was just one of the most magical sights that I've seen, and I hope you all put it out on YouTube, and everyone can see it.
It's going to be out there soon. We're writing, of course, a paper out of that, which we hope is going to have a lot of impact. But yes, it's going to be out soon. Don't worry.
Right. So now we come to, inevitably, all the ethical dilemmas that surround humans and technology. And it was, I began to ask you those questions. You said there's very deep thinking going on about what are the dilemmas of what you're trying to do, Are we going to listen in and understand nature? Are we going to disrupt nature by doing this? Do humans have the right to talk to other species? Tell us what you all are thinking about this.
Well, the thinking is exactly along the lines that you were explaining. So imagine you have this power of understanding what they're saying, okay? You could use this for good. For example, you could change cargo shipping lanes so to reduce the pollution, noise pollution that these animals are experiencing, so make their life better. But at the same time, if they have some communication system that is structured enough and some notion of consciousness, or at least, this kind of intelligence you would imagine, then we need to take them seriously as, persons with rights. And one of the rights is, for example, right to privacy. Should we listen to them? And how should we decide whether we use our power on them and so on? So some of the thinking is, along really these lines is sort of shaping some guardrails that we are trying to develop in collaboration with other people who are thinking about similar things for similar topics for, plants, trees, and so on. There is a whole movement called More Than Human Life we're collaborating with to try and put out legal guardrails of how we should move, how we should treat these animals. And of course, as you can imagine, we are the ones enacting anything, so we need to, for example, borrow legal information, legal structures from, for example, the laws that we have to care for children because they cannot protect themselves. So this is the kind of thing that we are thinking about, and I think this is a great place to discuss this thing, because the provocation that you had, is it a time for a constitution for technology? I would say yes, but also for species, an interspecies constitution, something that allows us to set up a framework to interact, to cooperate across the whole spectrum, from bacteria all the way up to possibly superhuman intelligences.
I'm going to end very soon, Giovanni, and thank you very much for this. I had one other question. One is about listening in. Do you think that it would be possible that through AI, it could become translational, and would other species be able to understand what humans are saying?
Well, I certainly hope so. I have my doubts. So my day job is in neuroscience, information theory, group coordination. And as I was saying earlier, these are animals that experience a world that is radically different. So it's not just about how predictive your brain is in this case. They live in a different world, right? Maybe they don't have the concept of wetness.
They don't have concept of?
Wetness. What is water? We don't have a concept of airiness. We feel wind, but we don't feel airy, right? right? Why should they feel wet, right? So if you are trying to translate to another language, then you need to take into account how the difference in cognitive structure that is a result of the environment in which you live is going to affect your capacity to translate, to map one on the other. Definitely we can do something in the direction, and sci-fi is full of this example, and I think we can get there, and we are getting there. But there will be limits to that. At the same time, there is a power. I mean, before coming up, I had a thought. How many of you learned a language when they were adult, new language? Because many people here multilingual. Okay, what happened to me is that every time I learned a new language, French and Portuguese, it felt like a whole new world opened up because I could read that literature. Now, it's a little bit like that in this case. If we cannot access how they feel, how they perceive themselves, but if we can access communication, then we have a window in and we can understand how they're thinking, what they're perceiving, and that is probably the closest we can get to.
Thank you very, very much, Giovanni. It's really been amazing to hear this. I hope at the speed at which things are moving that next year we'll have David Gruber and Giovanni telling us what their first contact with whales, what was the first words that we heard of another human, another non-human. Thank you, Giovanni. Thank you very much.